Good morning or afternoon or evening, whenever you're watching this. And today we're going to be performing Lab 16A on the calculation of the specific heat of an unknown metal. I want to point out a particular piece of information that you should remember, that the heat gained by the water is equal to the heat lost by the sample. So if you know the mass of the water, and you know the change in temperature of the water, and you know the specific heat of the water, you can find Q, which is the heat gained. If you know the heat gained by the water, now you know the heat lost by the metal. If you know the heat lost by the metal, the mass of the metal, and the temperature change of the metal, you can calculate the specific heat. So here's the link to the lab, and the first thing it's going to bring up is this page, and you're going to want to click on experiment. Now if you want to run the demonstration, you can, but if you think you got a handle on it, we'll just go to the run experiment. And the first thing that we want to do is choose what solid we're going to test. So I'm going to pick the drop-down menu, and we're going to test unknown metal 1. We're going to adjust its mass all the way up to 50 grams, and we're going to adjust its initial temperature all the way up to 200 degrees Celsius. Since we're trying to find the specific heat of unknown metal 1, I would prefer that you didn't click the show the specific heat button. But if you choose to do that, as it says in the lab, you'll need to show the calculations that support this specific heat. So I'd rather you just calculate it anyway, but I'll leave that up to you. Once you have selected unknown metal 1 and you've adjusted its mass to 50 and its temperature to 200, you're going to click Next so you can choose the liquid that we'll be performing the test with in this part, which is our calorimeter. We're going to pick water. We're going to leave its initial temperature at 20 degrees Celsius, which is room temperature, but we'll adjust its mass all the way up to 200 grams. So you can see we've got an initial temperature of the metal sample of 200 degrees Celsius and an initial temperature of the water sample at 20 degrees Celsius. If you want to show the specific heat of water, you can, but you should know that it is 4.18. We're going to click on the Next button to get our experiment ready to run. And if you want to show the graph view, you can. It doesn't really provide any other additional information, but you can if you want to. And then we'll click Start. The specific heat of the metal sample goes in the calorimeter, the stir bar starts, and this will tell us what the final temperature of the metal is. That's all you're doing. When you get the final temperature, you'll record that here. So you know the initial mass of the metal sample. You know the initial mass of the water because you adjusted those. You know the initial temperature of the water because you set it at 20. And you know the initial temperature of the metal sample because you set it at 200. You're going to record the final temperature of the water and the final temperature of the metal sample, and according to this graph, they are both the same thing. So your final temperature of metal sample and final temperature of the water should be the same. You want the delta T of the water so that you can calculate the Q gained by the water. If you know the Q gained by the water and you know the mass of the metal sample, the Q lost by the metal sample, which is the same as the heat gained by the water, and the delta T, you can find the specific heat. You're going to repeat this experiment 3 times and take the average, but this is a pretty repeatable experiment, and I'll leave that up to you. You're going to do the same thing for unknown metal 2, and please show your calculations. Okay. The last thing you're going to do is perform the test on one of the known metals and calculate its specific heat. Here are specific heats of some known metals, or you can simply go to the experiment, and when we reset it, we'll pick as our solid one of these that are known: tin, silver, copper, iron. If you do that, you can simply show the specific heat, and what we're going to do is calculate it using the same procedure. Adjust the mass to 50 grams. Adjust its temperature to 200 degrees Celsius. Click Next. Choose water as our liquid. Adjust its mass all the way to 200. Leave its temperature at 20. And run the experiment. And we'll calculate the specific heat of a known metal that we can compare using the percent error. All right, that's the whole thing. You'll have all of today and all of Monday, and at any time, ask me any questions. When in doubt, if you think I'm going to be looking for a particular calculation, put it in there. You'd rather it be there and not need it than it not be there and need it. All right, I'm online if you have any questions. Have a good day.